ಸೊ ನಮಸ್ತೆ ಎವ್ರಿವನ್, ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲ? ಸೊ ನಾನು ನಿಮ್ಮ ವಿನಾಯಕ್, ಕೆಮಿಸ್ಟ್ರಿ ಫ್ಯಾಕಲ್ಟಿ. ಸೊ ಇಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು MCQ ಸೀರೀಸ್ ಆಫ್ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಸೊ ಈ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಏನು ಕಲಿತಾ ಇದ್ದೀವಿ ಅಥವಾ ಏನು ಮಾಡ್ತಿದ್ದೀವಿ ಅಂದರೆ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಆಫ್ ಸೆಕೆಂಡ್ PUC. ನಿಮ್ಮ ಸೆಕೆಂಡ್ PUCಲಿರುವಂತಹ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಒನ್ ಶಾರ್ಟ್ ವಿಡಿಯೋ ಆಗಿ ನಾವು MCQಸನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ರಿಲೇಟೆಡ್ ಇಂಪಾರ್ಟೆಂಟ್ MCQs. So in this video we are going to see from D and F block elements. Along with that, along with the D and F block elements we are going to learn coordination compound. So ಈ ಎರಡೂ ಚಾಪ್ಟರ್ನ MCQs ನಾವು ಈ ವಿಡಿಯೋದಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. So let's begin with the class. First question is, according to IUPAC, transition metals are defined as. So this question we are going to observe in NCET first topic. So metals which have incomplete d subshells either in neutral atom or in their ions, metals which have complete d subshells in neutral only atom, metals with chemical properties were transitional metals or transitional between those S and P block elements, metal with chemical properties were transition between those P and F block elements. So among four, option A is the right answer. So metal which have incomplete d subshell either in neutral or in their ions. So you can take copper as an example. So next question. So the correct electronic configuration of Cr is, so chromium. So we know that option D is the right answer. 4s1 3d5. So this is exception, remember this. 4s1 3d5, not 4s2 3d4. Okay, yes. In third question, which of the following pairs both elements do not have same outer shell electronic configuration? Yes, so we'll check for copper with argon 18, then 3d10 4s1, right? For copper 3d10 4s1. Now same thing you check for zinc, then you will get argon with 18 3d10 4s2. If you see this outer electronic configuration in this d10 4 or d10s1, here d10s2. So both are having different outermost shell electronic configuration. So which option is correct? Option C. So you can check for silver also. So silver Ag, if you check, krypton 4d10 5s1. Then if you see for Cu and Ag, for these two they have similar electronic configuration d10 and s1. So this is s1. So which option is correct now? Third option. So next question. In general, the melting and boiling point of transition metals increase gradually across the period from left to right, decrease gradually across the period from left to right, first increases till the middle of the period, then decreases towards the end, first decreases regularly till the middle of the period, then increases towards the end. If you see one point, we know that melting point is completely depend on number of unpaired electrons is directly proportional to melting point or boiling point. Now if you see here d1 d2 d3 d4, so how many unpaired electrons? 1 unpaired electrons. How many unpaired electrons? 2, here 3, here 4. Same thing if you check for d5, here 5 unpaired electrons. Now same thing if you are writing for d6, then you will get 4 unpaired electrons. For d7 you will get 3 unpaired electrons. Same way for d8 you will get 2 unpaired electrons. Now, in the textbook, if you observe the graph, so it will increase at certain time and then again it will start decreasing at the end. So option C is the right answer. Now, fifth one, the correct order of melting point. So always remember one thing, we know that melting point is directly proportional to number of unpaired electrons. That is correct. Now we also know that manganese will show here abnormal melting point. Exception, abnormal melting point. So now chromium is having electronic configuration 3d5 4s1. So how many unpaired electrons? 6 unpaired electrons is present. So because of that, which option is correct? Option C is the right answer. Sixth one, which one of the following does not correctly represent the correct order of the property of indicated against it? So ಈ ಪ್ರಾಪರ್ಟೀಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದರ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇನ್ಕ್ರೀಸಿಂಗ್ ನಂಬರ್ ಆಫ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್, ಸೊ TiV chromium manganese correct ಇದೆ. So option B, that is also correct. If you check the electronic configuration, then you will get. Third option you see, increasing melting point. Just now we saw that manganese will show here abnormal melting point. So by seeing this only we can predict option C is the incorrect. See, they asked does not correctly represent. So option C is the right answer. Now seventh one, the element having minimum volatility among the following is. So one point you remember, this volatility is inversely proportional to melting point or boiling point. So among this, which one will be having highest melting point or boiling point? So according to textbook, we'll be having tungsten. But remember, majority of the times we are going to use osmium in our daily life. So as scientist tells that more than tungsten, osmium we are going to use. Because of that, option C is the right answer. So more the melting point or more the boiling point, less the volatility. So among these four, osmium shows minimum volatility. Yes. So ನೀವೆಲ್ಲ ಆಲ್ರೆಡಿ CET ಎಕ್ಸಾಮಿಗೆ ಪ್ರಿಪೇರ್ ಆಗ್ತಿದ್ದೀರಾ. ಅದೇ ಫಿಸಿಕ್ಸ್, ಕೆಮಿಸ್ಟ್ರಿ, ಮ್ಯಾಥ್ಸ್, ಬಯಾಲಜಿ, ಸೇಮ್ ಸಬ್ಜೆಕ್ಟ್, ಸೇಮ್ ಸಿಲೆಬಸ್. ಒನ್ ಮೋರ್ ಎಕ್ಸಾಮ್ ಯು ಕ್ಯಾನ್ ರೈಟ್, that is NCET, ನ್ಯಾಷನಲ್ ಕಾಮನ್ ಎಂಟ್ರಾನ್ಸ್ ಟೆಸ್ಟ್. ನೀವು IITಗೆ ಸೇರ್ಕೋಬೇಕು, NITಗೆ ಸೇರ್ಕೋಬೇಕು ಅಂದರೆ ಯು ನೋ ದಟ್ ಓನ್ಲಿ ಒನ್ ಎಕ್ಸಾಮ್, ದಟ್ ಇಸ್ JEE. Now from last 3 years, one more exam you can write to join IITs, NITs and RIEs. Indian Institute of Technology, National Institute of Technology and Regional Institute of Education. ಸೊ ಇಲ್ಲಿ ಏನು ಈ ಕೋರ್ಸಲ್ಲಿ ಏನು ಸಿಗುತ್ತೆ? BSc B.Ed, BA B.Ed, BCom B.Ed, ಈ ಮೂರು ಕೋರ್ಸು ನಿಮಗೆ 4 ಇಯರ್ಸ್ ಇಂಟಿಗ್ರೇಟೆಡ್ ಕೋರ್ಸ್ ಇದೆ. ಈ 4 ಇಯರ್ಸ್ ಇಂಟಿಗ್ರೇಟೆಡ್ ಕೋರ್ಸಲ್ಲಿ ನೀವು ಏನೇನು ಕಲಿತಾರೆ, ಇಟ್ಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ರಿಲೇಟೆಡ್ ಎಜುಕೇಷನ್. ಇದರಲ್ಲಿ ನೀವು ಟೀಚಿಂಗ್ ಫೀಲ್ಡಿಗೆ ಯಾರು ಹೋಗ್ಬೇಕಂತಿದ್ದೀರಾ, ಸೊ ದೇ ಕ್ಯಾನ್ ಅಪ್ಲೈ ಫಾರ್ ದಿಸ್ ಎಕ್ಸಾಮ್. ದಿಸ್ ಈಸ್ ಫ್ರಮ್ the same NTA, National Testing Agency, which will conduct JEE and NEET exam. Same team is going to conduct. Now application already started from 12th February. Then what is the last date? 10th March is the last date. If anyone is interested other than this engineering and doctor, so they can sure apply for this exam. So one more way to join IITs, NITs and topmost colleges. Yes, we'll continue. So the next question, the correct statement among the following is: metals with very high enthalpy of atomization tend to be noble in their reactions. Metal with very low enthalpy of atomization tend to be noble in their reactions. Metals with very low enthalpy of ionization tend to be noble in their reactions. Metals with very high enthalpy of atomization tend to be highly reactive in their reactions. So option A is the right answer. Next, ninth question. Statement 1, statement based question. So metals of the 4D and 5D series having greater enthalpies of atomization than the corresponding elements of 3D series. Okay. Statement 2, more frequent metal-metal bondings are found in compounds of the heavy transition metals. So both statements are correct here. So metals of 4D and 5D series are having greater enthalpy of atomization because of compared to 3D series. So why it is having more greater enthalpy? Because of frequent metal-metal bonding. So option C is the right answer. So 10th one. In transition elements 5D and 6D series, a regular decrease in atomic radii. A regular decrease in atomic radii. So we know that this is because of lanthanide contraction. So which option is correct? N-1F before NZ. Option A is the right answer. So the element with least density. So if this is memory based question, so always remember scandium. Scandium is the least element which is having least density. Okay. Next question. 12th, exchange energy is approximately proportional to total number of possible pairs of parallel spins in the generate orbitals, total number of possible pairs of anti-parallel spins in the degenerate orbitals, total number of possible pairs of parallel spins in the degenerate orbitals, total number of possible pairs of parallel spins in generate orbitals. See, among all four options, if you see, they changed only one word, generate, degenerate, degenerate, generate. Now, so which option is correct for this? If you see here, total number of possible pairs of parallel spins in the degenerate orbitals will help to get maximum exchange energy. So option C is the right answer. Now 13th one. The electronic configuration of Cr is 3d5 4s1 instead of 3d4 4s2 due to, so from 9th or 10th onwards we are knowing this answer. The energy gap between two sets 3d and 4s of outer orbital is small enough to prevent electron entering 4s orbital. Option B is the right answer. Yes. 14th question. The common oxidation state shown by the element with atomic number 21. So atomic number 21. So which element atomic number 21? Scandium. Scandium will show here +3 oxidation state. So option A is the right answer. Now 15th one. The maximum oxidation state shown by vanadium, chromium, cobalt, scandium respectively. So we know that vanadium will show +5 oxidation state, chromium will show here, if you write electronic configuration, then you will get +6, then manganese will show here +7 oxidation state, then along with that cobalt will show here +4 oxidation state, scandium will show here +3 oxidation state. So which option is correct? Option A is the right answer. Okay. Now 16th one. Among Cu, Hg, Cd and Cn, which is or not regarded as a transition elements? So they are asking which will not belongs to transition elements. So now, see here for copper, we know that copper in normal state, it will not produce any unpaired electrons, but copper in copper in +2 stage, it will produce here argon with 4s0 3d9. So 9, that means how many unpaired electrons present here? One unpaired electron present. So easily it will show transition element characteristics. But what about mercury? So which option is correct now? Option C is the right answer. Mercury, cadmium and CN. These are the three elements which will not belongs to transition elements, but it belongs to D block elements. Yes. 17th question. The D block elements not having general electronic configuration. Yes, there is some change or error in this. So this will be n minus 1 d 1 to 10, then ns 1 to 2. So this is the general electronic configuration. Okay. So the D block element not having general electronic configuration, we have to check now. So which element? Option B. If you check here for PD, you will get 4d10 krypton, 4d10 5s0. So this is the electronic configuration. So PD is the right answer. So zinc, chromium and PT will show here. 18th one. 4 successive members of the first series transition metals are listed below. For which one of the standard potential value has positive sign? So we know that even in NCET in text question they gave this. Copper will show here positive sign in standard potential. Copper is the only element. What is the value? Plus 0.34 volt. So remember this. So remaining all elements will show negative potential. So 19th question. Exchange energy is maximum in. So you should know here maximum number of possible energies exchange. When it will happen? More number of oxidation state. So manganese will show here maximum exchange energy. Because unpaired electrons, it can shift from one place to another place. Yes. 20. The most stable manganese compound is. So among these four, which one is most stable we have to find. Now see here, option C is the right answer. Now if you check oxidation state for all manganese, for these two it will come +4. Among these two, MnO2 is naturally available. So it is naturally available. Because of that, we are going to consider MnO2 is most stable manganese compound, not MnF4. Okay. Now 21st. Which of the following statement is wrong? In highest oxidation state, the transition metals show acidic character. Correct. Mn3 plus and cobalt 3 plus are oxidizing agents in aqueous solution. Correct. Metals in highest oxidation states are more stable in oxidation than fluorides. Correct. All elements of 3D series exhibit variable oxidation state. So this option is wrong. So we know that there is one element scandium which exhibits only +3 oxidation state. So incorrect, they asked which option is wrong. So option 4 is the right answer for this question. 22nd. Identify the set of paramagnetic ions among the following. Yes. So we have to identify what is the major condition. Paramagnetic means unpaired electrons should be present. And among the four options, we have to find among which among the following groups we have to we are getting unpaired electrons. 22nd, option C is the right answer. Titanium 2 plus, copper 2 plus, manganese 3 plus. So if you write electronic configuration, then easily you can get. So in Mn3 plus, we have 4 unpaired electrons. In copper 2 plus, you will get 1 unpaired electrons. In titanium 2 plus, you will observe here 2 unpaired electrons. So maximum number of unpaired electrons we are going to observe. So option C is the right answer. So what about 23 question? Identify the correct sequence of number of unpaired electrons of the following ions. See here, option B is the right answer. Twenty-third question. Identify the correct sequence of number of unpaired electrons among the following ions. See here. So if you check for Fe3 plus, then chromium 3 plus, for nickel 2 plus and titanium 3 plus. So how many unpaired electrons for Fe3? If you check, you will get 5 unpaired electrons. For chromium, you will get 4 unpaired electrons. 3 unpaired electrons. Yes. Identify the correct sequence of number of unpaired electrons of the following ions. Now, if you check for Fe3 plus, chromium 3 plus, nickel 2 plus and Ti 3 plus. For Fe3 plus, we know that 5 unpaired electrons will be present. For chromium 3 plus, 3 unpaired electrons will get. For nickel, we'll get 2 unpaired electrons, and for titanium 3 plus, we'll get 1 unpaired electron. So if you arrange, you will get Fe3 plus, then chromium 3 plus, then titanium 3 plus, then nickel 2 plus. See, according to number of unpaired electrons, first I have to write Ni2 plus, then Ti3 plus. But exception is there. Always remember, Ti3 plus is more stable than Ni2 plus. So because of that, we are arranging like this. So option D is the right answer. See, they gave 2 options also. So we have to check based upon the stability, we have to identify. So for 23rd question, option D is the right answer. So 24th. A compound of metal ion M plus Z equals 24 has spin only magnetic moment of 15 Bohr magneton. The number of unpaired electrons of compound. So they gave already value 15, that equals square root of n into n plus 2. So both side, if you multiply with squares, then you will get 15 equals n into n plus 2. Then 15 equals n square plus 2n. Okay. Then n square plus 2n minus 15 equals 0. If you solve for this equation, you will get n is equal to 3 and n is equal to minus 5. So unpaired electrons will not be present in negative numbers. So we'll consider n is equal to 3 is the right answer. So which option is correct? Option D is the right answer. So next question, 25th. Which of the following does not represent property against it? See, they gave elements along with that their property. So if you check for ionic size, 25th question, if you check for ionic size, it is correct. Mn2 plus is having more ionic size, correct. Then for number of oxidation state, if you check, this is also correct. Manganese is having highest oxidation state. So for third option, paramagnetic behavior, Fe2 plus is having paramagnetic behavior. That is also correct. Now fourth option is the wrong option. So scandium, chromium and iron. So regarding density, it is wrong. Okay. So which option is correct now? Option D is the right answer. For 26th question, statement based. So statement 1, Fe3 plus ion shows paramagnetic and magnetic moment of 5.92 bm. Statement 2, Fe3 plus ions have D3 electronic configuration. Now, if you see here, Fe3 plus is paramagnetic, correct? And it is having unpaired electron, 5.92. But Fe3 plus ion have D3 electronic configuration. So, if you check for D3, square root of 3 into 3 plus 2. 3 is the square root of 15. Square root of 15. If you see just 5 point, it will come as a square, it will come 25. So it is not near to this also. So statement 1 is correct, but number of unpaired electrons is wrong. So option D is the right answer. Now 28. The stability of particular oxidation state of metal in aqueous solution is determined by, see, enthalpy of sublimation of metals, correct. Ionization energy, correct. Enthalpy of hydration of the metal ion, correct. So all of this is the right answer. 28. In aqueous solution, electronic configuration of Cu2 plus ion is 3d9. Now, but electronic configuration of Cu1 ion is 3d10. Which of the following is correct? So Cu2 plus ion is less stable, Cu plus 2 ion is more stable, Cu plus 1 oxidation state and Cu plus 2 oxidation state are equally stable, Cu plus 1 oxidation state is more stable. So which option is correct now? Cu plus 2, copper plus 2 is more stable. Always remember, in aqueous solution. In gaseous solution, remember, if they changed question, if in gaseous solution copper with plus 1 oxidation state is more stable than Cu2 plus, but in aqueous solution 3d9 is more stable than 3d10. So second option is the right answer. For 29th, the stability of Cu2 plus aqueous rather than Cu plus aqueous due to, so just now we saw here for 29th question, B is the right answer. More negative hydration of Cu2 plus than Cu plus. Yes. For 30, match the following. Yes. If you see among these, for anyone, whichever you know. So this nickel will helps to hydrogenation of the fat for 3D. Which option is? So all three is having 3D. Then you check for vanadium pentoxide contact process for 4B. So these two are having 4B. Then you check for first one, manufacture of polythene. So for first option C, so B is the right answer. So PDCl2 is Waker process. Yes. Next, which of the following is not a condition for complex formation? Small atomic size, correct. Higher nuclear charge, correct. Variable oxidation state, no. Availability of vacant orbitals, correct. So option C is the right answer. So they are asking not a condition. 32. The correct increasing order of oxidizing power. So if you check here, option A, for all the transition elements, if you check oxidation state, option A we are going to get correct increasing order of oxidizing power. So option A is the right answer. Then 33 statement based question. So first statement, potassium permanganate is powerful oxidant. Okay. KMnO4 oxidize I minus to IO3 minus in acidic solution. Yes, both are correct. So both statement 1 and 2 are correct. 34. The product obtained when I minus react with KMnO4 in faintly alkaline or neutral medium solution. So what will get I minus? So always remember I minus will be converting into IO3 minus. This complete reaction is available in your NCET. So please go and refer that. Okay. 35th. Which of the following statement is not correct? See, KMnO4 oxidize iodine into iodine in acidic medium, correct. Permanganate is diamagnetic, correct. Copper liberates hydrogen from acids. So this is wrong. So Ti2 plus liberates hydrogen from dilute acids, correct. So if you see electrochemical series, copper is below hydrogen. So it can't replace the hydrogen. So which option is correct? Option C is the right answer for this. 36. The reaction of aqueous KMnO4 with H2O2 in an acidic condition gives, for H2O2, acidic condition. So in acidic condition, KMnO4 is present in the form of Mn2+. So H2O2, it will release in the form of O2. So which option is correct for 36? Option B is the right answer. So 37. The oxidation state of chromium in the final product formed by the reaction between potassium iodide and acidified potassium dichromate solution is +3 oxidation state. Oxidation state of chromium. So in the final product formed by reaction between potassium iodide and acidified potassium dichromate. So chromium is having +3 oxidation state. 38. Which of the following statements is not correct? A. Scandium does not exhibit variable oxidation state. Brass is an alloy of copper and zinc. Actinoids contraction is greater than lanthanide contraction. Mn2+ is colorless. See, Mn2+ is having unpaired electrons. It is, if colorless means either it should be having D0 or D10. But Mn2+ is having unpaired electrons. So it is colored compound. So option D is the correct answer. So 39. The basic oxide among the following is. See, we know that chromium oxide will act as a basic oxide. So any element which is having less oxidation state will act as a basic. So any element or metal which is having more oxidation state will act as a acidic. So in between they will act as a moderate. If the oxidation state is moderate, then they will act as a amphoteric. So which acts as a both acid and base. Now next 40th. The correct decreasing order of ionic character in the following oxides is. See here, option B is the right answer. The correct decreasing order of ionic character of the following oxygen. So here +2, if we check for this, manganese is having +7. So decreasing order. So MnO2 if we calculate, we will get +4. Yes. Now next, the composition of chromite ore. So we know that FeCr2O4 is the composition of chromite ore. 42. Choose the correct increasing order of oxidation state of the central atom in the following oxyons. Oxoanions. VO2 plus, VO2 plus, TiO2 plus and Cr4 minus. So I think this molecule repeated 2 times. So VO2 plus and okay, 1 second. So this is just a VO2, not VO2 plus. VO2 plus, TiO2 plus, CrO4 2 minus. So among these 4, if you calculate the oxidation state, so first we'll calculate for vanadium oxide for vanadium X plus 2 into minus 2 equals 0, then you will get X minus 4 equals 0, X equals 4. So if you calculate for VO2 plus, then X plus 2 into minus 2, that equals plus 1, then X minus 4 equals plus 1, then X equals plus 5. Same thing if you calculate for titanium oxide TiO2 plus, then if you see here X plus 2 into minus 2, that equals plus 1, then you will get X equals plus 5. Same thing if you check for chromium CrO4 2 minus. So X plus 4 into minus 2, that equals minus 2. So X equals, so X minus 8 equals minus 2. So X equals, so plus 8 plus minus 2, then you will get plus 6 oxidation state. Now which one is having highest here? CrO4 2 minus. So all 3 are having CrO4 2 minus. Then, so between TiO2 plus and VO2 plus, which option is correct? So now if you see which option is correct, option B is the right answer. So minimum oxidations for VO2. So among these 4, option B will be the right answer. Okay. Then next question. Which of the following pair of metal oxides are amphoteric? So just now we studied that amphoteric means which will show both acidic and basic character. Among this, which metal or which element is having moderate oxidation state? Check. If you observe for option A, which is having moderate oxidation state, so plus 5 here, plus 3, so which will show both acidic and basic characteristics. So option A is the right answer. So the transition metal A forms highest oxidation state only with oxygen, which is acidic and covalent, and its divalent ion has maximum magnetic moment. It oxidizes iodide ion to iodate ion in neutral medium. The metal is. So they are telling transition metal A forms highest oxidation state. So we know that which element is having highest oxidation state? Mn. So in the presence of Mn2 plus, it is having maximum magnetic moment. So option B is the right answer. So 45th, in the dichromate dianion, the nature of bonds are. So dichromate diion, Cr2O7 2 minus. So it's like CrO, Cr with O minus, minus. If you see the structure, now 4 equivalent CrO bonds are present? No. 6 equivalent CrO bonds and 1 OO bond? No. 6 equivalent CrO bonds and 1 CR bond? No. 6 equivalent CrO bonds and 1 CrO bond. So option D is the right answer. 46th question. A mixture of NaCl and K2Cr2O7 is heated with concentrated H2SO4, so deep red vapors are formed. Which of the following statements is false? So this is previous year question paper. So if you remember, they are asking false. The vapors given yellow solution with NaOH. So which test this is? This is chromyl chloride test from salt analysis. If you remember, sodium chloride plus K2Cr2O7 heated in the concentrated H2S4, you will get red vapors. So the vapors contain, if you see here, vapors contain CrO2, Cl2 and Cl2, correct. The vapors contain only CrO2, Cl2. This option is wrong. So they are asking false. So the vapors contain CrO2, Cl2 only. This is the wrong option. The vapor when passed with lead acetate in acetic gives yellow precipitate, correct. The vapors gives yellow solution in NaOH, correct. So option C is the right answer. 47. The ability of fluorine to stabilize the highest oxidation state of transition metals is due to highest lattice energy and high bond enthalpy. So remember this. 48. Match the following. So along with central metal and complex we have to identify. Now check for a blood pigment iron. So if you check for chlorophyll, in chlorophyll magnesium is present. So which option is there for B3? Okay, here these two options, A, 4. So option B is the right answer. For C, vitamin B12, we know that cobalt, then Wilkinson catalyst, RH. Okay. So option B is the right answer. So 49. Which of the following transition metals cannot displace H2 from acids? Just now we studied that copper is present below the hydrogen in electrochemical series, so it can't replace the hydrogen. So option D is the right answer. 50. Statement based questions. So copper displaces H2 gas from dilute acids. Now statement 2, Cu2 plus ions get reduced more easily than H plus ions. So we know that copper can't displace H2 plus. First of all, first statement is wrong. So option B is the right answer. Statement 1 is incorrect, but statement 2 is correct. Cu2 plus ions get reduced more easily than H plus ions. 51. Lanthanides reacts with water to form. So we know that lanthanide hydroxide, LnOH twice. So 53. The radius of La3 plus is 106 picometer. Which one of the following given values will be closest to radius Lu3 plus? So this question is based on your NCET graph which is present in lanthanide contraction. Okay. So if you see the graph, here atomic number, here ionic size. So it will start from La3 plus, then slowly it will decrease after increasing atomic number, but ionic size is decreasing to Lu3 plus at last, which is having the least picometer. So among 4 options, if you observe anyone is having less than 106, that will be the right answer. Option D is the right answer. So 54 question. So which of the following oxidation states is the most common among the lanthanides? Most common. So we know that scandium is having +3. So along with that, majority of the elements will show +3 oxidation state. So option A is the right answer. What is the percentage of lanthanide metal in mixed metal? So we know that 95% is lanthanide. So 55 is option D is the answer. 56. Incorrect statement with reference to CE, Z equals 58. So this is the CET previous year question paper. If you observe here, C plus 4 is reducing agent they are telling. So this is wrong. It will act as a oxidizing agent. So it will act as a oxidizing agent. B. C in plus 3 oxidation state is more stable than plus 4. Correct. Atomic size of C is more than Lu. Correct. C shows common oxidation state plus 3 and plus 4. So option A is the right answer. 57. Although plus 3 is the characteristic oxidation state of lanthanides, but cerium also shows plus 4 oxidation state because cerium plus 4 will be having noble gas configuration 4F0, 5D0, 6S0. This is exception. Remember this. So option C is the right answer. So they can give this in the form of fill in the blanks or 1 marks question. So the correct statement is the extent of actinide contraction is almost as same as lanthanide contraction. Correct. C3 plus in aqueous solution is not known. Wrong. The earlier members of lanthanide series resembles calcium in their chemical properties. Wrong. In general lanthanides and actinides does not show variable oxidation state. Wrong. So which option is correct? Option A is the right answer. So 59th. Trivalent lanthanide ions to be colorless is R. If you see here, trivalent lanthanides. So EU will be converting into U3 plus, then La will be converting into La3 plus, then ER will be converting into ER3 plus, then CE is converting into CE3 plus. Among these four, which lanthanide ion will be colorless? So colorless means we know that it should be having 0 unpaired electron. So La3 plus is having 4F0. So this option will be the right answer. 60. Lanthanides on heating with carbon producers. So these are chemical properties of lanthanides. Mixture of Ln3C, Ln2C3 and Lnc2. Option A is the right answer. 61. Reason of lanthanide contraction is. So what is the main reason of lanthanide contraction? Negligible screening effect of f orbitals, right. Increasing in nuclear charge, no. Decreasing in nuclear charge, no. Decreasing in screening effect, no. So option A is the right answer. Identify the incorrect statement from the following. So I have to identify incorrect statement. So zirconium and osmium have identical radii, 160 picometer and 159 picometer respectively, consequence of lanthanide contraction. Correct. So they are asking incorrect. Lanthanides reveals only plus 3 oxidation states. So no, it is having plus 3 plus 4 oxidation state. The lanthanides other than the F0 type, the F14 type all are paramagnetic. Correct. The overall decrease in atomic and ionic radii of lanthanum to lutetium is called lanthanide contraction. Correct. So which option is wrong now? Option 2 is wrong. So for this question, which option is correct? Option B is the right answer. 63. Now, because of lanthanide contraction, which of the following pairs of elements are nearly same atomic radii? So we know that zirconium and hafnium will be having same atomic radii. Yes. 64. Match the following. So along with elements and properties we have to identify. So potassium dichromate, manganese, lanthanum and chromium. 64. See, For manganese, it will show +3 and +5 oxidation state. Correct? So now, for lanthanum, it will show multiple oxidation state from Yes, 64th question. Match the following D and F block elements with their properties or reactions. So potassium dichromate used in breathalyzer test for detecting alcohol. Correct. So for A, 2. Manganese will show here +2 to +7 oxidation state. So if you check for B3 among these 4 options, A is the only option which is showing for B, third option. So which is the correct answer? Option A is the right answer. 65th, actinides will show maximum oxidation state. So option C is the right answer. NP will show maximum oxidation state. 66. The reason of greater range of oxidation state in actinoids is attributed to actinide contraction, 5F60 and 7S levels of having comparable energies, 4F and 5D levels being close in energies, the radioactive nature of actinoids. So option B is the right answer. 5F, 60 and 7S levels having comparable energies. The incorrect statement among the following is, actinides are highly reactive metals, especially when they are finely divided. Correct. Actinide contraction is greater for element to element than lanthanide contraction. Correct. Most of the trivalent lanthanide ions are colorless in the solid state. We have to check. Then lanthanides are good conductors of heat and electricity. So this is also correct. So option C, if you check, most of the trivalent lanthanide ions are colorless in the solid state. No. So option C is the right answer. So they are asking incorrect statement. 68. The correct increasing order of oxidizing power. So oxidizing power, so for usually fourth option we can rule out because manganese will be having +7. Now between vanadium and chromium, now for chromium we'll get +4. So now among these two, so I think both are having same option. So option B will be the right answer.